Alright, let's wrap it up with the arithmetics. There is one final thing that we have to see. This is the different ways that we have to multiply two vectors. We have the dot product and the cross product. And I will show you a few ways to perform these calculations. At least for the dot product there are two ways. For the cross product there is one way that I know of. So dot product produces one scalar number. Dot product requires two vectors of the same size and they are multiplied element by element, and then the sum of these elements is taken. Now, two ways to do this. Dot product. The first way is to do it like this. Version 1. So we get the first vector and we multiply it by the second vector. But the second vector needs to also be transposed. What does transposing mean? Transposing means that if we have the vector 1, 2, 3 and we transpose it, it will turn from a row vector into a column vector. So we will get 1, 2, 3 in a column variant. So when we transpose our second vector here and we multiply it by the first vector, we will get 1, 2, 3 vector multiplied by a column vector of 3, 5 and 4, like this. Otherwise it's not going to work. So if we run it like this, we get an error. We saw this in a previous lecture, so we need to transpose it. Transposing is done by using a single quotation mark. So if I use second vector here, we get it like this. If I say second vector with a single quotation mark, we get it in a column. So if I do this, run, the dot product is 25. Now, the second way to do this is by simply using v2, by simply using the dot function. The dot function requires two vectors. First vector, second vector. Let's run it, and we still get 25. 25. So both of these ways work. The difference between the two ways is that the function gives you a little bit of flexibility when it comes to multidimensional vectors, which you will see shortly. So if you're strictly working with two one-dimensional vectors, you can use either of these two ways. Actually, I haven't experimented to see which one performs faster, which one calculates it faster, but maybe we will do this as an exercise sometimes. Alright, let's move on to cross product. There are many ways to calculate cross product on paper. The cross product between two vectors yields another vector that is perpendicular to both of the crossed vectors. And if you have to perform a cross product at some point, well, you probably know what a cross product is. So let's do it. So cross product equals we have a function for this, so it's a cross, first vector, second vector. Let's run it, and we get a third vector. These are the coordinates of this vector. So usually when we are working in 3 dimensions, this is the x, the y and the z. When we take the cross product of these two vectors, we get a third vector with a different set of x, y, z coordinates. This third vector is perpendicular to these two vectors.